It's that time again. Hello, this is Mr.Sanemon with another A+ tutorial. Today we're going to be doing our long overdue A Brief History of Form Factors study guide. So I say brief history because really they expect you to know almost anything that really ever caught on. Way back into the 80s. Stuff that's completely irrelevant, but they expect you to know it for your test. They may not need more, but they did when I was studying for it. So, well, we'll start where we should start. What is a form factor? And over here, you'll see my diagram, and you'll see my little key. Red means case, green means motherboard, blue means devices, and purple means fan. And then below you'll see Form A and Form B. And you notice there are some differences. First of all, you'll notice that the fan placement is different. These are not actual form factors. I mean, they kind of resemble, the one on the left kind of resembles one, but you'll notice that there are different fan placements on each of them. The blue right here is definitely going to be the power supply, CPU, RAM modules, and then peripherals up here, and then riser cards, so on and so forth. So form factors are going to be how the motherboard connects. So they're going to be different things. Like in older motherboards, there might have been a riser card that contained your expansion slots, and a riser card was just an extension of the motherboard. And riser cards were often proprietary with proprietary connectors. So a form factor is essentially a standardized form for a shape of a case, all of its connections to the motherboard itself, and the placement of everything in it, except for the power supply, which on most form factors can be either top or bottom mounted. This is also going to have the way the power supply is mounted, as well as the way the motherboard is mounted, and the way that the fans circulate air. Now, in an ATX, or in Form A, you'll notice that the fan blows from the PSP power supply unit, blows air in over the CPU chip, and sort of walls on the RAM modules. And so in Form B, which is going to be the evolution, you'll notice the RAM modules have air flowing directly over them and into the CPU, thus giving more airflow and better efficiency. So let's go on and talk about our actual definition. So what is a power supply? You'll notice that I'm going to go ahead and read this, but you'll notice that it does have an explanation. In computing, the form factor is specifically is the specification of a motherboard that mentions power supply type, location of mounting holes, number of ports out on the back panel, etc. Specifically, in the IBM PC compatible industry, standard form factors, and this is a Y, standard form factors ensure the parts are interchangeable across competing vendors and generations of technology. While in enterprise computing, form factors ensure that server modules fit into existing rack mount systems. Traditionally, the most significant specification is for that of the motherboard, which generally dictates the overall size of the case. Small form factors have been developed and implemented. What most people are going to use is ATX, Advanced Technology Extended, as a motherboard form factor specification developed by Intel in 1995 to improve on previous de facto standards like AT form factor. It was the first major change in desktop computing enclosure, motherboard, and power supply design in many years, improving on standardization of interchangeability of parts. The specification defines the key mechanical dimensions, mounting point, I/O panel, power supply, and connector interfaces between a computer case, motherboard, power, and a power supply. We also use BTX, Balanced Technology Extended, and NLX. So, and we also use NLX from time to time, though there are better small form factor standards out there. NLX I've seen from time to time, so we'll discuss. So now we know what we use and why we use it and why we have a standard. ATX basically standardized everything and made sure that everything was compatible and everything connected properly, and didn't have much care for anything else like that. They weren't producing much heat at the time, so they didn't have to worry about how to get rid of that excess heat as much when ATX was first introduced. The technology that existed to alleviate heat was doing the job at the time. There weren't big riser video cards with dual fans that took up 2 PCIe times 32 slots back then. So you don't have to worry about heat as much at that time. Well, in 2004, and we'll go back over here and we'll show you what we've covered so far. We've covered why do they exist, which ones do we use, and now we're going to discuss where do we go now and why have they changed. So, ATX was introduced as a means to standardize all platforms to create a world with fewer incompatibility issues and to prevent the use of proprietary form factors. This form factor was not created to reduce heat or to conserve space. NLX was, however, designed to conserve space and to create a form factor that would manage energy efficiency and conserve space. This form factor is all about the budget and is often used in the office environments for its ability to conserve space on and around the desk and a lower power consumption. BTX was created for performance and for toppling the ATX empire. It was also created by Intel and is starting to catch on. It has features which reduce heat by strategically placing components in places that make fans more efficient. In high-end PCs, I don't see this really having much of an effect due to the wonders of liquid cooling. So, that was a pretty brief history of them. What is a form factor? It's the positioning of the components within a computer case and the motherboard. Why do they exist? To create a standardized set of rules for how things are going to fit in there so that any component can fit in any case, in any motherboard. Which ones do we use? Well, we use ATX most of the time. A lot of us use ATX or one of the variants of it. Why have they changed? They've changed to sort of match our needs of them. In the beginning, it was just to create standardization. Now it's to create energy efficiency or conserve space or to better manage heat from components. So there are many reasons. Why have they changed? Or rather, where do we go now? I think we'll probably start seeing more BTX boards. Maybe ATX will live for a while, but BTX boards are going to exist for a long time. And that's pretty much it, guys. If you have any other questions about form factors or anything like that, feel free to message me in the comment section below. Don't forget to rate, favorite, and subscribe. Thanks, and have a good one.